Our focus standard for this lesson comes from grade 7, Geometry, Standard 1, Solve problems involving scale drawings of geometric figures. Our topic for this lesson comes from AGR, Similar Figures. Our essential question is, how do we identify similar figures and what is the relationship between their measurements? Please take a moment pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set your question column and your note column, and resume the video when you're ready to begin. Today we're going to start by comparing and contrasting congruent figures, which we've talked about, to similar figures. So you may remember that congruent figures have the same shape and the same size. It's their angle measurements that give the shape, and it is the side lengths that give the size. So they have equal angle measurements when two shapes are congruent, and exactly equal side lengths. So we talk about them as being an exact copy, and that's sometimes helpful to remember with the CO here. Congruent figures are like a copy. Similar figures, on the other hand, do have the same shape, but they are different sizes. So notice these two figures here are similar. If I drag this over, you can see that I can line this up and notice that their angle measurements are the same size, but their side lengths are not. This purple quadrilateral is a smaller version of this larger red quadrilateral. Their angle measurements match up, meaning they're equal in measurement, but their side lengths are not. So similar figures have the same shape, but a different size. And we use just the squiggle line, the tilde, to show that two shapes are similar. Now let's go ahead and do some analysis on some similar figures. Let's start with the notation for similar figures. Just like we do with congruent figures, we can name congruent angles between similar figures because, as we just saw, their angle measurements are equal, but their side lengths are not. So I've listed out here the angles from the red quadrilateral here, and what I'd like you to do is match up what are the corresponding and congruent angle measurements from K, L, M, N. How did you do? So we should have that angle Q is congruent to angle K, angle R is congruent to angle L, angle S is congruent to angle M, angle T is congruent to angle N. Those are the ones that correspond and match up. Now let's go ahead and list the similar and corresponding sides. For example, we're starting here with side length QR. What is the corresponding side that matches up, that is similar, has the same kind of slant on this purple? Well, if you said KL, I would agree with you. So right here in this blank, we would say that QR is similar to the line segment KL. Let's go ahead and fill that in, and then see if you can fill in the rest of these. How'd you do? You should have that QR is similar to line segment KL as we started together. RS is similar to LM. ST is similar to MN. And TQ is similar to NK. Alright, now that we've discussed notation for similar figures, let's start to look for some patterns between how their corresponding side lengths are related in measurement. So here I've created two triangles just to try and keep things more simple. In all of our examples today, I have the figures oriented so that they would be in the same direction as their corresponding part angles and side lengths. So here I have triangle ABC, it's our green one here, is similar to triangle A prime, B prime, C prime. So that would be our blue triangle here. What do you notice about how the corresponding side lengths relate to one another. So here we have line segment AB is 10 inches, and that corresponding side over here would be side length A prime, B prime, and it is 5 inches. Line segment BC is 12 inches, and the corresponding side that matches up over here would be side length B prime, C prime, and it's 6 inches. On our final third side, we have line segment AC is also 12 inches, and the corresponding side length A prime, C prime is 6 inches. Is there a pattern that you notice between those corresponding measurements? If you notice, if we go from 10 to 5, those are corresponding sides, what would I have to multiply 10 by to get 5? Well, if you said 1/2, I agree with you. Does that also work for these other corresponding sides? Yeah, it does. So in each of these cases, starting with our first figure, triangle ABC, we have found that you can take each side, multiply it by 1/2, and find the length of the corresponding side on the next figure, triangle A prime, B prime, C prime. What this relationship is what we refer to as the scale factor. So the scale factor between these two similar triangles is 1/2. And we should remember that because we know that the word factor is part of a multiplication problem. So 10 times 1/2 is 5, 12 times 1/2 is 6. So the scale factor that relates the corresponding side lengths between these two similar figures is 1/2. Let's go ahead and try the next one. So here I've given us two similar trapezoids, saying that trapezoid ABCD is similar to trapezoid GHIJ. This time, you'll notice I gave you the measurements for our first trapezoid, but I haven't given them to you for the second trapezoid. The information that I have given is that the scale factor is 3. So, remembering what we know from up here and how we found the scale factor, do you think you can use the scale factor that I'm giving you to label the missing side lengths of the corresponding sides? Let's try one together, and then I'll let you try the rest on your own. So once again, these are oriented so that they're facing the same direction as their corresponding side lengths. So our line segment AD is 3 millimeters, and the corresponding side is line segment GJ. If we know that this side length is 3 millimeters, and we're trying to find the measurement of this side length with a scale factor that we know is 3, we can just multiply the side length that we're given times 3 to find the new measurement. What would that be? Well, if you said line segment GJ would be 9 millimeters, I would agree with you. And we use that, taking the measurement of the corresponding side times the scale factor to find the missing measurement. Go ahead and continue and see if you can label the rest of the sides on our trapezoid GHIJ, and then check back to compare. How'd you do? Well, if you took each of these side lengths and multiplied them by the scale factor of 3, you would have found their corresponding side lengths. So scale factor is how we describe the relationship between the measurements of corresponding sides on similar figures. That's going to conclude our video for today. Please make sure that your notes are complete and come ready to work with more problems on similar figures and scale factor in class.